So I claimed that integration and differentiation are related, and the way they are related is contained here. So clearly an antiderivative has something to do with derivatives, right? It's kind of the opposite of finding the derivative, finding an antiderivative. And the theorem is as follows. If capital F is an antiderivative of the continuous function f on the interval from a to b, then the integral from a to b of small f of x dx can be calculated as capital F at the endpoint minus capital F at the initial point a, like this. And we will denote this in the following way. So we will make square brackets, put f of x inside, and then indicate that we take the limits x equals a and b. This notation just means this number. So we will not prove this, but we will give a sketch of the proof, which is sort of illuminating if you want to know how it can be that differentiation and integration are related. So first of all, we define a new function, f, not f, a of x. And this a of x is given by the integral from a to x, f of t dt. So now x is a variable, an external variable, and t is a dummy variable, right? So one can think of a of x as this area here up to here. There's a mistake here. It should say a of a is 0 and a of b is the complete integral. So what is the point? Well, the point is that if we take f of x and a of x plus h, so what is that? It's we subtract the two. What is this difference? Well, it's basically the difference between the area of this figure here and this figure here. Right? So this is the bigger, at least when h is positive, the bigger area, and f is positive. So and then we subtract the small area. So what we have left is basically just the area of this bit here. Agree? And one can calculate that for this particular choice here, it's 1.95, some number, at least when we divide by h. So what is h? H is just the length of this, right? So we have an area here, and this area is very close to the area of just this rectangle here, right? So in this case, f of x is 1.75. So a of x plus h is almost the same as the length of this rectangle times the height. The height was 1.75 and the length was h. So a of x plus h is almost the same as this area over here plus this area of this rectangle, which we can write like this. So if we subtract a of x on both sides and divide by h, then we see that a of x plus h minus a of x divided by h will be close to f of x, right? If this is almost equal to this, we can just isolate our f of x in this inequality, and then we will have an almost identity here. And of course, this becomes increasingly wrong as h grows, but it becomes increasingly true as h shrinks, right? The difference between this rectangle and the actual area gets smaller and smaller, right? So what happens if we look at this fraction here and take the limit h to 0? Well, what is this? This is a difference quotient, right? The difference between the the value of the function a at x plus h and the value at x divided by h. But that's exactly the same as the difference quotient we use to define the derivative, right? So when we take the limit over here, we in fact get the derivative of a at the point x, right? So a prime of x equals this limit here, but it's also equal to f of x, because in the limit, the difference here tends to 0. So in other words, a prime of x equals f of x. But this means that a must be an antiderivative of f. But we know that if a is an antiderivative of f, then so is any function obtained by adding a constant to this. So we get that the integral from a to b f of x dx, which is equal to a of b, right? That was how it was defined up here, right? But this we can also write as a of b minus a of a. Remember that this was supposed to be an a. But we can also write it as f of b plus c if we have any other antiderivative capital F, minus f of a plus c, because the two c's here cancel, right? This is just a f of b minus f of a. In other words, if we have any antiderivative of f, we can just find the integral by evaluating the function at the endpoints and then subtracting the right endpoint from the value at the right endpoint from the value at the left endpoint.